Did you ever wonder how a computer game could remember your name? Or keep your score? Or know when you reach a new level? This is accomplished by using variables. In this lesson, you'll learn about different types of variables and how they can be used to develop your algorithms. Last lesson we learned that we could take text inputs. We could request input from our user via a question. And then, knowing that every time we ask a new question, the answer will change, we can actually pull that so that it saves permanently. So an example would be asking what's your name, and then waiting for the user to type their name, and then we would be able to set username to whatever they type. And we can use that later on in our program. In programming, variables are used to, first of all, to store information, and that information can then be referenced. We can manipulate that information. An example of just storing information would be to store the username. And then secondly, our variables allow us to give a descriptive name to some data that we need for our program. So for an example, you can see here that I have a variable called score, and it's very clear what that is. It's for a user to be able to accumulate their score. And with the combination of these two things, with the username and the score, we can actually combine that to make our program interactive. So when the win condition is met, we have our username and we can personalize the win message. Think of variables as plain old containers. All they do is hold the information. And their purpose is to label the information and to store it away in memory. An example would be plain old Tupperware containers. That's where you put all your leftovers and then you put them in the fridge. However, it's much more useful to everyone else who might be going through the fridge when they're hungry if you label those containers to let them know what is in the container. And if it's anything like my house, you just don't know what you're going to get unless that label is there. So some common variable types. There are different types of information that we want to store based on what it is that we're trying to do. So here are some common variable types. Very frequently, as we've already seen, we want to store information as just a number, as a whole number, an integer. For example, when we turn a certain number of degrees, that's an integer that lets it know what the turn is, how many degrees the turn is. A character. There you see some characters on the screen that you can type with the keyboard. Essentially, it's like one thing that you can type on the keyboard, like a letter. Now, when you start putting those letters together to make words, now the term for that is a string. Just like you string things together and now their string of characters makes a word or something that has significance. For example, the word cat. The letter C plus the letter A plus the letter T gives us CAT, which we now have meaning for. We also have Booleans, and we've seen these. Those are the hexagons in Scratch, and those are variables that represent either true or false. Or if you really think about it, they might represent 0 or 1, or they might represent on or off. It just kind of depends on the way that you're thinking. An example would be a variable such as, like if you're looking at a robot program, one of the robot problems on the AP practice problem. A lot of times there's a variable can move right, and it can either be true, yes, the robot can move right, in other words, it's not blocked, but if that way is blocked, can move right is false, and you can conduct the flow of your program based on that. So an array are lists of variables. As an example, we might have an array of test scores. So one person might take, let's say, 5 tests over a semester, and that data is kept in a list. So the test scores are kept in a list associated with one particular student. So an example would be 95, 100, 50, 82, 76. And of course, you can use this array to draw some information and to figure out the average and things like that. And lastly, there's a floating point number. And that might sound a little strange, but what this has to do with is the way that a computer stores a number. We know that real numbers are basically like any number that you could put on a line, pi, something like that, that has a whole lot of digits in it. This gives the computer the option to store that information by maybe having one section in memory that holds on to the significant digits or the main part of the number, and then another section that tells what is the exponent and the base of that exponent. And so essentially, if you see the example, we've got a number like 500,000, And we could, of course, put 0.00 on the end, and it doesn't change the value, but it does have a decimal point. And that might be an amount of money or something like that. But the computer maybe would rather store that number as 5 times 10 to the fifth. Store the 5 and then have another way of representing that it actually is multiplied by 10 to the fifth power. So it sounds fancy, but all it means is just a decimal number, and the computer has the flexibility on how to save that decimal number and how precisely to save that decimal number. So how do those variable types match up in Scratch? Well, we've already looked at an integer. Integer might be a score, and it might have a value of 10, but we know that it's going to have a value of, however many points you can earn by doing certain things. So it's never going to need a decimal point if you only increment your score by 1 or 2 or 5. Here's an example of a character. You might store a variable called letter grade, and it could be an A, hopefully it is, or a B or C or something else, and that's just a single character. A string, if we were going to have an animal, we might have to have a string of characters to tell what our animal is. For example, moose. We've looked at booleans before. These are our hexagons, and we know that that boolean can be used to have selection happen, like if the mouse is down, you will do something, but if it's not, you won't do that thing, if it's true or if it's false. You can find out whether it is true or false by clicking on the block itself, and it will report whatever value it currently has. Here's an example of the same 5 test grades stored for a student in an array called test grades. So the same numbers, it's holding on to all of them at once. And then for floating point numbers, as I said, the computer kind of has some flexibility with how it stores and how it displays numbers. And as an example, you can see that the Y position for sprite 1 at one particular point in time is being reported as 19 with actually 6 numbers after the decimal point. Probably in your programs, those digits probably won't matter too much, and it probably could, you just round it up to 20 and you wouldn't be able to tell the difference in that position on the screen from 19.88 to 20. But the computer has the flexibility to show that. Sometimes you might get answers when you're using some math and you're doing some calculations in your programs. Sometimes you get answers that aren't what you expect. They have more places, more decimal places than they should. And that's just because of this thing where the computer is just taking advantage of the fact that it can store numbers in a way that is best, instead of always rounding up to a certain number. You can always do that in the program. You can set it to round if you need it to. In many programming languages, the term for saying that there is going to be a score in your program, that there is going to be a username in the program, the term is declaring. And typically you do that at the very beginning of your program, because as you go through your program, it's going to be easier to code and easier to debug. From programming language to programming language, it's going to be different in exactly how you need to declare your variables. Sometimes when you declare your variable, you do have to tell what kind of variable it's going to be. Is it going to be an int or an integer, or is it going to be a string? Sometimes you have to do that. Other times you just set the value to the variable and it will be assumed, well, you just set this animal variable to the word cat, so clearly this is going to be a string variable. And it all depends on which programming language you're using and how you need to use that variable. All right, so here are some important things to remember when you are using variables. Your variable name, when you declare a variable, it can only hold a certain type of data. So you can't declare that you have an integer variable and then later on use it to hold a string. You have to maintain the data type. In some languages, you have to declare the variable before you use it. It won't accept a variable that is written into a function that hasn't been declared in the beginning. It'll give you a syntax error, but some will. You can only use a variable name once in your program. You cannot use that same name later on, even if you're done with that previous variable. You know, you're on a level 1 of a game and you've had a variable and now you want a new variable in level 2. it's going to be the same variable. And if you want it to be a different variable, you have to have a new name. So again, sometimes you have to tell what type of data is going to be held by your variable, and sometimes you don't. In Scratch, you don't. We saw that you can set a variable to a number or to a letter or to a string, and it will just accept that, and then from then on it will be that type of variable. You can give any name to variables. Remember, the computer doesn't care, and it really doesn't matter what you call your variables, except that you want to be able to read and debug your code, and you want other people to be able to read and debug your code. So therefore, it does matter to you, the programmer, that you choose appropriate names for your variables. It makes everything easier. All right, so once we were declaring variable, how do we set the value that we want the variable to start with? For example, a score variable. Once somebody has played our game and they've reached the winning condition, maybe they had to score 20 points and they earned it, and now we want to start back over, so we need to reset the value of our variable. We don't want to change it because we don't know how much we need to change it by. Maybe they didn't do very well and they only got 10 points and then they quit. Then we would need to change it by -10. But if they won and they got 25 points, then we need to change it by -25. So we don't know. We don't know what to change it by. So therefore, we have to set it to the value that we want. All right. So to do that, what you will do is use a single equal sign. All right, so if I want my score to go back to 0, I will say score equal 0. All right, and that assigns the value that I want my variable to have. So in the example down here, you can see that we've got a variable called first name. That underscore is there because you don't use spaces in the names of your variables. You don't do that. So that's the name of the variable. And secondly, we can see that it's being set to the string. Those quotation marks mean a string value. And it's being set to the string ADAM, or Adam. And we have meaning for that. We know that that is someone's name. The computer does not know. It's just a string to the computer. What we used right there was the single equals. And so we've set the variable. So a single equal will assign the value to the variable. Now, once the value has been set and your program is running and your variable maybe has changed, maybe, you've checked to see whether or not the winning condition has been met. So that is a different situation. We don't want to set the value anymore. We want to leave the value where it is, but we do want to compare it. So we're looking at this time, not a single equal sign, but a double equal sign. All right, and so that's what we need to use when we want to compare. Like I want to compare and check to see if score is equal to 25, which is my win condition. All right, so that's when we use the double quotes. Again, variable over on the left, and then the quantity that we're comparing the variable to goes on the right. So down here, we've got this right here. We want to know, does A equal 5? Well, it'll evaluate to true if it really is. It'll evaluate to false if it's not. And then we can use that in a conditional statement. Like if A equals 5, then you can do something in your program. Whereas if A does not equal 5, maybe the user needs to go back and do something over to get A up to 5. All right, and so comparison is a different story. So when we're using our value, our variable, and we want to compare it to something, then we use the double equal sign. But when we're just setting the value of the variable, we use the single equals.